Hi, and welcome to part 6 of the June 2021 Maths crash course. Today, the first question we're going to be seeing is actually a cumulative frequency question. Now, cumulative frequency, right, just in case you didn't know, falls under statistics on the CXC syllabus. So just some advice, first of all, if you never did a cumulative frequency or you're not at all familiar with the statistics part of the syllabus, I have a few videos that I did that explains most of the statistics. So let's go. All you have to do is go on YouTube, type in iLoveLessons statistics. Now a lot of my videos will pop up. The one that you want to the tool, that you want to concentrate on is, you will see one titled video 63 called cumulative frequency. Of course, you need to watch that video. The video has a lot of graphs in it because cumulative frequency is a graph type of question. So if you scroll down a little bit, you will see understanding graph paper, video 61. So I would suggest you watch video 61 first and then move to video 63. Take my advice, even if you think you know a lot about graph paper, you probably need to know the real specific parts about graph paper, because there are a lot of tiny details that you need to cover in graph paper. All right, so just take my word for it. Look at video 61 first and then go to 63. All right, and of course, if you want to watch statistics, like everything in statistics are talking about mean, mode, median, and everything, I have a video here. It's called The Legend of Pi Chi, right? I tried to explain the whole of statistics in a very fun way. It's very long, but it's very, very detailed. And everything in the video pertains to the CXC type of questions. All right, guys, so let's move on. So today's explanation is going to assume that you know a little bit about cumulative frequency and you at least took the time to go through the videos. So you have a cumulative frequency curve here, right? It shows the age of 48 trees. So let me just zoom in here a little bit. The y-axis is showing you the cumulative frequency, and the x-axis is showing you the age of the trees. What they want you to do is find the upper quartile. Now, to find the upper quartile, what we need to do is take the amount of trees first of all. Remember, there are 48 trees. So, what we're going to call this value n. N is just the amount, the total amount in the question. So in today's question, it just happens to be 48. What we need to do is take n and add 1. We always add 1. And for upper quartile, we need to multiply it by 3/4. Okay? So let me just put the 3/4 in front. Right? I just feel more comfortable with having the 3/4 in front. So we take n plus 1 and we multiply that value by 3/4. So let's see where this leads us. Now I have limited space here, so I'm just going to draw a dashed line here. 3/4, and how much is n? N is 48, so it's 48 plus 1. When we work this out, let me go to the calculator here. 3 divided by 4, that's 3/4, multiply by 49, because 48 plus 1 is 49. So when we do this, we get 36.75. 36.75. Now, 36.75 is not our answer for the upper quartile. It will help us find the answer for the upper quartile. So what we need to do is go on the y-axis and look for 36.75. Now, I'm going to have to approximate where this is. So using here's 30, let me zoom in here, right? So if we zoom in, here is 30, 31, 32, 33, 34, 35, 36, 37. 36.5 will be somewhere in between the 36 and 37 mark. Now the program I'm using, I can't draw a straight line, but what you will need to do is take your ruler and go straight across. I'm going to try my best to go straight across. When you go straight across, you will eventually come in contact with the curve. When you come in contact with the curve, drop it straight down. And the number it falls on is the upper quartile. So it looks like we dropped somewhere, and it looks between 20 and 21. So I mean, remember that I don't have the program here. I can't really be too accurate because I can't draw a straight line. But we're going to assume that the upper quartile, the answer is 20.5. So to find the lower quartile now, we do almost the same thing. We say n plus 1, but lower quartile means we multiply by a quarter instead, not 3/4. Upper quartile is 3/4. Lower quartile is 1/4. So it's a quarter of 48 plus 1. Let's work this out on my little calculator here, right? 1 divided by 4 is a quarter, multiplied by 49, the 48 plus 1. And we get 12.25. All right, now 12.25 is not the answer for the lower quartile. We have to use this to get the final answer for the lower quartile. So let's zoom in here. Let's go to the y-axis and look for 12.25. Well, if here's 10, here's 11, here's 12, here's 13. 12.25 will be in between the 12 and the 13. So once again, we move across. We will come in contact with the curve. Wherever it hits the curve, drop it straight down. Let's see where this lands. Let's zoom in here a little bit. Here's 0, 1, 2, 3, 4, and 5. It's between 4 and 5, so we're just going to approximate it to 4.5. So the lower quartile is 4.5. Let's move on to the median. Now, you see how we have upper quartile, lower quartile? Median means middle or halfway. So we're going to do the same exact thing. N plus 1, but this time the fraction is a half. So it's a half of 48 plus 1, right? Let me work this out. A half of 48 plus 1. 1 divided by 2 is a half, multiplied by 49, and we get 24.5. Once again, this is not the median. We have to use the graph, we have to use the 24.5 to get the median. So let me zoom in here, guys. A little clunky, but we'll get there. 20, 21, 22, 23, 24, 25. 24.5 is in between the 24 and the 25. So we go across. Wherever it hits the graph, we drop it straight down. So this one looks like it's going to drop straight on 10. So it seems that our median is 10. All right, so that was a brief question on upper, lower, and median quartiles. All right, so now on the same graph, they want us to, well, let me just read the question. How many trees were less than 20 years old? Now keep in mind there are 48 trees in total, right? Remember they mentioned that at the beginning of the question. You see, they told you there were 48 trees in total. anytime you read a value of the y-axis, it is automatically less than. I didn't work out too good, so I'm going to erase that. All right. It's automatically less than. So they want you to figure out how many trees were less than. Lucky for you, they are asking a less than question. 20 years old. So the x-axis tells us the tree, and they're talking about 20 years old. So we look for 20, and this time we go upwards instead. And when we go upwards, we will come in contact with the graph, and then we will go across. Right, so I have to zoom in. I know I did a kind of bend there, but if you had a physical graph paper printed, it would have been a little bit easier for you to, do. So let me do back this part. I'm trying to get, so let's say it hits the graph somewhere here, and if we go across, right, that is we're going to assume it's here. That's 30, 31, 32, 33, 34, 35, 36. So it hits the y-axis at 36. Lucky for us, whenever we read off a value on the y-axis for a cumulative frequency curve, it is automatically less than. So guess what? The answer is 36. 36 trees were actually less than 20 years old. Now, they asked a slightly different question. How many trees were more than 20 years old? Now, if there are 48 trees in total and 36 are less than, shouldn't the balance be more than, right? Think about it in something more relatable. If there were people in a room, say there were 20 people in a room, and I told you 15 were short, right? How many would be tall, would be considered tall? Won't it be 20 minus 15? It's the same thing here. They're asking, do you see how short and tall are opposites? Well, they're asking less than and more than. So if there are 48 in all and 36 were less than 20 years old, then the other amount, the remaining amount would be more than. So all we have to do is take the 48 and minus the 36. So 48 minus 36 is 12. So that's the final answer for that one. All right, so let's make a note here. So this is question 6, part 5. All right, so moving on. Find the probability of choosing, this is my fault here, of this supposed to be choosing a tree more than 20 years old. Now, to calculate the probability, right, what we need to do is, when you're calculating probability, the denominator is always the total. So we have 48 trees in all. The numerator is supposed to be what you care about, or what you are considering. They want you to find the probability of choosing a tree more than 20 years old. But that means part 5 will help us. How many trees were more than 20 years old? 12. So that's the probability, and if we reduce it, we will get a quarter. That's the answer for the probability. So in a probability question, just remember the total is always your denominator, and the numerator is what you care about or what you are considering. All right, so that's the end of part A. Now remember, at the beginning of this video, I had suggested that you watch a couple videos on cumulative frequency. And I'm going to try to drill it in your head, because this question here is what I consider a very easy question because they already drew the graph for you. In the harder type of questions, you won't have the graph. It will be your job to draw the graph and then answer all of these questions. All right, so take my advice, guys. Once again, make sure and watch the videos I suggested at the beginning of this video. Part B. The diagram shows a trapezium. Okay, well, a trapezium has 4 sides. 1, 2, 3, 4. And before we even move into this question, because I know what the question is about, all the angles in any 4-sided figure will add up to 360 degrees. Any 4-sided figure. Trapezium, parallelogram, square, rectangle, all of them, if you add up all the internal angles, you get 360. They want you to work out the value of y. That's this length here, right? So, let's see. First of all, if I draw a line coming down here, so let me draw. It will make a 90 degrees here. So immediately I see a kind of, well, not kind of, it is a right angle triangle. Let's just call here A, here B, here C, where this imaginary line hits, that's D, and over here could be E. All right. So here's what I propose, right? AB is 37. That means from E to D only. Remember, you're seeing a kind of rectangle here. A, B, D, E. The opposite sides of a rectangle must be equal. So that means here is 37. Now, y is the entire distance from E to C. So, if we were to find DC somehow, if we were to find this distance, if we were to find this DC, which is x, and add it to 37, we will get the total distance y. So let's just concentrate, I have some space here, on the right angle triangle. Now, there are a couple ways to get out this question, right? Now, if here's 15, then the opposite side of the rectangle from B to D is also 15. And here's C. Here's 90, here's 90, here's 125. I bet we could find this missing angle because all 4 angles are supposed to add up to what? 360. Remember, I just said all the angles in a 4-sided figure add up to 360. So let's do a little calculation here. We have 290 degrees, 90 plus 90 plus the 125 gives me how much? 305. So 360 minus 305 will give us 55. So this angle here is 55 degrees. Now we have to use our sine, tan, or cosine. Remember, we want to find this distance here. So if I'm using the 55 degrees, if I'm standing here, here's the opposite side, and x is the adjacent side. So that's tan. So tan theta is opposite over adjacent. Tan 55, which is the angle we are standing up in, is the opposite, which is 15 centimeters, divided by the adjacent, which is x. So tan 55 is the same thing as tan 55 on 1. I run another space on this side, so I'm just going to do the work in here. Let's cross multiply. X by tan 55, x multiplied by tan 55 is equal to 15 by 1 is how much? Just 15. So that means x is equal to 15 divided by tan 55. We throw across the multiply, we get a divide. Let's just type this in on the calculator quickly. 15 divided by tan 55 is roughly 10.50. So that means this distance here is 10.5. Well, 0 if you want to put it in. So that means the total distance is 37 plus the 10.5. So that means y is, if I think I could do this in my head, 47.50. 37 plus the 10.5, or centimeters. And that's the final answer for this particular question. That's part B. All right. Part C. All right. So, first of all, this is a kind of continuation of the question above a little bit. I said any triangle, right? Any triangle, all the angles inside add up to 180. Any four-sided figure in the world, a quadrilateral, all the angles inside add up to 360. We just mentioned that. But what about if you have a five-sided figure, or a six-sided figure, or a 10-sided figure? How much would all the angles add up to? There's actually a formula for that. To figure out how much all the angles add up internally in a shape, you can use this formula. N minus 2 multiplied by 180, where n is the amount of sides present in the shape. Now, let me see if I can prove this to you. A triangle has three sides. We all know all three angles has to add up to 180. So let's just see if the formula works. A triangle has three sides, so that means we can replace the n with 3. N is the amount of sides in the shape we are considering. According to the formula, we always minus 2 and then multiply by 180. 3 minus 2 is 1. 1 by 180 is 180. Right? So the formula, I'm just trying to prove to you that the formula actually works. So let's see what this question is asking us about. They want us, let me just get to the point of the question. Calculate the size of angle EDJ. EDJ. All right, that means they are asking for this angle here. EDJ, I guess it's angle D. They're asking, oh, they already have it laid out. It's this angle here. So they're asking for that angle. All right. First of all, there's an isosceles triangle here. You notice the examiner put a stroke here and a stroke here, which means that this angle and this angle is the same. So let's find this angle first. I think that could help us out, okay? So let me zoom in here a little bit. In an isosceles triangle, right? If this is 30 degrees and these two angles are supposed to be equal, then we can take 180 minus the 30 and divide the answer by 2. So let me work this out. 180 minus 30 divided by 2. So that means both of these angles each is what? 75 degrees. So I'm going to use a different color so everything will stand out a little better, right? So we just reason out that this blue angle here is 75 degrees. I suggest now that we find this green angle here. And after we find this green angle, we will be able to find the one with the dot, the one that the question wants us to find. So how do we do that? I want you to pay attention to the bigger shape. You notice this is, yeah, let's count how much size this shape has first of all. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we were to add up, now they said this is a regular nanogon, which means all the sides have the same length, which means all the angles inside have the same value, all of them. That's what regular means. It means all of the angles will be the same and all the sides have the same length. So since this is a 9-sided figure, we could figure out the sum of all the angles inside the 9-sided shape. All we have to do is go and replace n with 9, like I did with the triangle, except with a 9, and multiply it by 180. So let's work this out. 9 minus 2 is 7. So 7 multiplied by 180 is, well, 1260 degrees. Now, the thing about it, that's if you add up all the angles inside here. Remember, there are 9 identical angles inside here, and all of them add up to 1260. So that means we have to divide it by 9 now to get the size of each individual interior angle. Divided by 9, I hope I get a good number. Yes, 140. So that means, let's write this a little better. Right, so that means each of these are 140, including the green one. So let me zoom in here. 140. Now, to find this angle here, the one with the dot, you have to remember a circle is 360 degrees. You see a circle here? If I start here and spin all the way around and come back to the dot, that forms a circle. 1, 2, 3 are supposed to add up to what? 360. So that means if I add the 140 and the 75 and minus it from the 360, then I will get Mr. D here, which is what the question is asking me for. All right. So let's see. 3. Let me add it up first. Sorry. 140 plus 75. That's 215. So 360 minus 215, and that's 145. So this angle here is 145, which is what the question was asking us for. All right. So that's all. Question 6. I'm just making a note of something here. How to part 5. That's all. Right. So I'm just double checking something to make sure everything is okay. All right. Cool. Scrolling down. Oh, and well, you all know the usual ad. Like, once again, guys, if you need extra lessons in almost any, well, in these subjects here, and you're interested in joining the classes, you can just give me a call. But it's only for persons in Trinidad and Tobago. And of course, if you want to help me share my flyer, even though that you may not be joining the lesson, you could find my number in the description below. Feel free to WhatsApp me, and I could send you it, and you could share it on various social media to help out. Okay. All right. That's all. I just had to make a few notes for this video, for today's video. All right, cool. Scrolling down. Part D. Now this here is a speed time graph question. Now, unfortunately, I don't have any videos explaining speed time graphs, okay? And honestly, I didn't do a check to see. So I'm going to try my best to explain the theory as I go along. So here we have a speed time graph. Speed is on the y-axis and time is on the x-axis. What are they asking us to find here? In this one here, for the graph, find the acceleration for the first 4 seconds. So the first 4 seconds is up to here. So it starts here and the first 4 seconds end here. In a speed time graph, the gradient always gives us the acceleration, right? So in a speed time graph, now there are 2 types of graphs on the syllabus when it comes to movement like this. There's speed time graphs and distance time graphs. Don't mix them up. Make sure you read the y-axis. So to find the acceleration in a speed time graph, they're already asking us to find the gradient. To find gradient, you know the symbol for gradient is m. You know it's y2 minus y1 divided by x2 minus x1. Right, so we need 2 points here. The first point, the beginning point, is 0, 0. And where the graph is ending, he looks like 4, 8. 4 on the x, 8 on the y. Call the first point x1, y1. The next point, what? x2 and y2. And just throw it into the formula, and we will get the acceleration. So y2 minus y1. y2 is 8, y1 is 0. 8 minus 0. x2 is 4, and x1 is 0. So it's just 8 divided by 4, which is 2. And, well, in case you didn't know, acceleration is 2 and is measured in meters per second squared. And that's the end of that question. So in a speed time graph, the gradient tells us the acceleration. Right. Let's move on to the next one. Now here's another speed time graph. But this time they're asking us for the total distance traveled. Now, gradient will give us the acceleration. However, when they ask you for the distance, they want you to find the area under the graph. So, and unfortunately, they want to know the distance for the whole graph, which means we have to find the area underneath the whole graph, which means we're going to have to divide this up into different shapes. So that means I'm going to have to put a triangle here, a rectangle. If I draw a straight line here, I will get a rectangle and a triangle. So we're going to try to find the area of 1, 2, 3, 4 shapes. Okay? So the area of a triangle is base by height divided by 2. So for a triangle, it's just base by height divided by 2. And for a rectangle, well, we all know it's length by breadth. So we just had to find the area of all 4 shapes. So let's get some lengths going here. Let's get the length of everything here. We get a different color here. All right. From here to here, right, is 4. From 0 to 4. So we know here is 4. And the height here, which is also the part of the rectangle here, how high, this red line here, how high is it? It's 8. So we have the base and we have the height. For the rectangle shape too, we don't have the length, but we have the breadth. The breadth is what? 8. How much is from here to here? You have to be careful. Don't say 14. It starts at 4 and it ends at 14. So 14 minus 4 is 10. So from here to here is 10. We know here is 8, so the opposite side of the rectangle is also 8. Here's 14, here's 20. It starts at 14, it ends at 20. So that's 6. From here to here is 8. If here is 8, then here has to be 8. So what's the distance from here to here? Well, look at it properly. Starts at 8 and it ends at where? 10. Starts at 8 and ends at 10. So this distance here is 2. So all we have to do is find the area of each shape. So for where can I find some space to write here? Oh, I have some space here. For shape 1, it's just base by height divided by 2. 4 by 8 divided by 2. That will give us 16, right? So that will give us 16. 2 for shape 2 is just length by breadth. Length by breadth. 10 by 8, which is 80. Shape 3, length by breadth. 6 by 8. That will give us 42. And for the triangle on top, base, remember if here is 6, then here's also 6. Base by height divided by 2. Base by height divided by 2, we will get 6. We just add up all 4 answers and we have the total distance. 16 plus 80 plus 42 plus 60, 144. So the total distance is 144 meters. All right. Okay. Let me see what we have here now. We have another speed time graph. Oh, but lucky for us, it's based on the graph above. For the speed time graph, they ask us for the average speed. Now, this is a formula you need to remember. To calculate average speed, you have to take the total distance they are talking about and just divide it by the total time. Now, they're asking you for the average speed for the full 20 seconds. That's for the full graph. Remember, the total distance, we calculated it above. The total distance was 144. And how much was the total time for the entire journey? Well, 20 seconds. And you just divide the 2, and that's it. 144 divided by 20 is 7.2. And speed is in meters per second. Because, well, you see the speed here, they have the unit. Meters per second. All right, so moving on to the next graph, okay? Now, if I'm if my voice, if I'm slurring a little bit or making some mistakes, it's because I'm really sleepy and I'm doing this just before I go to bed. All right, so the graph below, I love this one. This is a distance time graph now, not a speed time graph. So they're showing the distance moved by a car. What is the speed in section A? In a distance time graph, okay? In a distance time graph, the gradient, right, gives us the speed. Don't mix it up with a speed time graph. In a speed time graph, the gradient gives us the acceleration. But if they change it to a distance time graph, the gradient represents the speed. So they want what? The speed in section A. So we know here 0, 0. At the end of section A, that looks like what? 25, 50, if I'm not mistaken. You know this is x1, y1, x2 and y2. You just throw it into the gradient formula. y2 minus y1 divided by x2 minus x1. So, let's see. y2 is 50 minus y1 is 0. x2 is 25. 25 and x1 is 0. So you end up with 50 divided by 25, which is 2. So that means the speed is 2 meters per second. Speed is measured in meters per second. Now they want the average speed. Remember the formula for average speed? We did it up here. Total distance over total time. So to calculate the average speed, we have to take the total distance and divide it by the total time. Now, remember, this is a distance time graph. The y-axis represents the distance. Look at the highest point here. At the end of the entire journey, his distance was 80. So the total distance was 80. How long did this take? Remember, the x-axis tells us the time. The total time was 70 seconds. So it's just 8 divided by 70. And we get 1.14 meters per second. Okay. Oh, that's the end of what? That's the end of question 6. Now, just give me a few seconds. I want to explain this a little better for you. This honestly, this distance time graph and speed time graph, honestly, I don't think I did the best job here. So let me move ahead here. When it comes to these graphs, there are two types of graphs. There is one called a distance. I don't know why this pen is giving trouble. 1 second, guys. Just be a little patient with me. It's worth staying on for this. There's one called a distance time graph and one called a speed time graph. Right? In the distance time graph, the distance goes on the y-axis and the time goes on the x-axis. In a speed time graph, it's almost the same thing, except the speed goes on the y-axis and the time goes on the x. In a distance time graph, the gradient gives us the speed. The area in a distance time graph gives us nothing. Nothing of importance. In a speed time graph, the gradient will give us the acceleration, right? And the area in a speed time graph gives us something useful. It gives us the distance traveled by the object. And it doesn't matter which graph you use here. Anytime they ask you to calculate the average speed, I don't know why this on. Anytime they ask you to calculate the average speed, anytime they ask you to do that, you just have to take the total distance they are talking about and divide it by the total time it took. All right, so make sure and take down these notes because it's real easy to mistake the distance time graph with the speed time graph. And of course, the gradient and areas in each type of graph gives you different types of information. Okay? Now, if you're not familiar with finding areas or the speed, or gradient, make sure and look for videos online explaining how to find gradient or how to find areas of basic shapes like rectangles and triangles. Okay? All right, guys. So thanks for viewing this video. Right? I was a little fidgety today. I'm really tired. But thanks for watching. Of course, don't forget to share, to subscribe. Of course, tell anybody you know about these videos, especially if you know they are writing CXC and could use the extra help. Take care, guys, and stay tuned for video 7.